Hello everybody, in this video we will discuss how to solve problem based on one-dimensional motion in gravitational field. In my view, problems based on a freely falling object can easily be dealt with help of Galileo's law of odd numbers, which is based on his famous experiment carried out by Italian scientist Galileo. Is said to be dropped spheres from Leaning Tower of Pisa. First, we will analyze his experiment with help of kinetic equation. Distance traveled by a particle in nth second is given by Sn equal to u plus half a within bracket 2n minus 1, isn't it? If a body is freely fall, u is nothing but 0. Here the acceleration a is nothing but g. Now we are going to substitute the values. Sn equal to 0 plus half ag 2n minus 1. That's why equation is going to be reduced half g within bracket 2n minus 1. Now we are going to calculate the distance traveled by freely falling object in consecutive second. First of all, in the first second. For that, what we are going to do, we are going to place n equal to 1. That's why S1 equal to half G 2 n is 1 minus 1. It is equal to 2 minus 1 1. That's why G by 2. G we can take the 10 by 2 equal to 5 meter. That is, in the first second of journey, the particle has to be travel around the 5 meter. Similarly, we can calculate in the second of the journey, S2. What we are going to be put? You just think a while, n equal to 2. That's why 2 into 2 minus 1. That's the 3. The 3 by 2 g. G is 10. It is 30 by 2. What we are getting? 15 meter. Similarly, we can find the distance traveled by the particle during the third second of journey. You can also try yourself. Try. What you have to do? N equal to 3. You have to be put only half g within bracket 2 multiplied by 3 minus 1. 6 minus 1 5. 5 by 2 g. What we are getting? 50. Why? The g is 10. It is the 25 meter. Now we can find the ratio of the distances traveled by the particle in consecutive second. In first second 5 meter, 15 meter, 25 meter. That's why the ratio of distance traveled by the freely falling object in consecutive seconds S1 is to S2 is to S3 equal to 5, 15, 25 divided by the 5, 1, 3, 5. That's it. Let us take few problems on freely falling objects. First one, a ball is dropped from top of a tower falling through 40 meter during the last 2 seconds of its fall. The height of tower in meter is, suppose this is a tower and there is a ball. Suppose height of the tower is h and total time of the fall is t. First of all, we are going to solve this problem in conventional method, in which the equation of kinematics are used, which we already studied in previous videos. S equal to ut plus half at square, isn't it? Here in our problem, acceleration is nothing but g, which is due to gravity. Generally, we are taking the tan in calculation. If h is the total height and t is the total time of fall, and a is nothing but the g, we can place the value in this equation, s equal to ut plus half at square. What is u here is 0. 0 multiplied by t plus half g t square. Equation is going to be reduced. Half g t square. Why u is 0 here is during the free fall initial velocity is 0. That's why we are taking u equal to 0. If t is the total time of fall and in the last 2 seconds ball traveled the 40 meter, therefore h minus 40 distance traveled by the ball in the t minus 2 second only. This we can also apply. S is nothing but h minus 40, it is traveled in t minus 2 second, half g t minus 2 whole of square, and we are getting this second equation. Now we can substitute the equation in equation second the value of h and find the t, and substituting the value of the t in equation first, we can get the value of h. This is a conventional method, a tedious method. No one wants this method. I'll show some techniques. Look at the diagram. Say this is the first second, second, the third second. We know in the first second, the distance traveled by a freely falling object is the 5 meter. In the second, the 15 meter. And the third, the 25 meter. In the problem, it is mentioned the ball traveled 40 meter during the last 2 seconds. In consecutive second, if you see carefully, you can get the last 2 seconds is nothing but the second and the third second, because this is only the case in which the 15 plus 25 we are getting the 40 meter. In the last 2 second distance traveled is nothing but the 15 plus 25 40 meter. Before that only the ball fall the 5 meter. The total distance is nothing but 5 plus 40. Therefore height of the tower is nothing but h equal to 5 plus 40 45 meter. Wow, how easy to solve via this technique. Next problem. Second problem. Two balls are dropped from same height at an interval of 1 second. The separation between two balls after 3 seconds of the drop of the first ball. Okay, say this is the tower, attractive one. And this is the height of the tower. First ball. After the fall of the first ball, we are going to drop the second one. First of all, we are going to solve by the conventional method. Again, we are going to utilize the second equation of motion, s equal to ut plus half a t square. During the free fall, we know the initial velocity, what we are taking, u equal to 0. And what about the acceleration? A is nothing but equal to G. Okay, we can substitute these two values for any height h. 0 multiplied by t plus half g t square means the equation is going to be reduced half of gt square. Suppose first ball is taking the time t1 and second is taking the t2. Then separation d is nothing but h1 minus h2, which is half g t1 square minus t2 square. What is h1 h2 here is? This is h1. Okay. This is h2. And separation of h1 minus h2 is nothing but the exact separation that is required in the problem. Okay. Then d equal to half. G is 10. T1 is almost 3 seconds minus 2 square. T1 is okay. That is given to us. The first ball is taking the time 3 seconds. Why I am taking the T2 is 2 seconds? Because second ball is dropped after 1 second. That's why I am taking T2 is nothing but 2. Okay. Now we can sort it out. D equal to 5 multiplied by 5. What we are getting? 25 meter. Okay. Now look at the same problem again by the technique. Look at the diagram. Without solve or exit any calculation, you can find the answer of this problem. Look, in first second, freely falling object travel the 5 meter. In the second, the object is travel the 15 meter, and the third second, it is the 25 meter. Means h1 is nothing but this total 5 plus 15 plus 25. h2 is 5 plus 15. The separation, it is very much transparent in the problem. It is the 25. The answer is 25. No need to calculation. Look, first ball traveled 3 seconds, but second ball traveled only the 2 seconds. The distance d is nothing but 25 meter. What a technique! No time to solve the problem, isn't it? Let's take one more problem on freely falling object on water drop. Water fall from a tap on the floor 9 meter below at regular interval of time. When first drop touches the ground, fourth drop just leaving the tap at this instant, height of second drop from ground is, say this is the tap and water drops are freely falling. It is the total height, the 9 meter that is mentioned in the problem. This fourth drop is leaving the tap. So this is the drop. In between there is a second drop and first drop is touching the ground. First of all, we are going to solve the same problem in the conventional way. in which we are using the equation of kinematics. S equal ut plus half a t square. U is nothing but the initial velocity, and during the free fall, what we are doing, U is nothing but what we will take 0. And what about the acceleration? A is equal to G. In SI system, what is its value? We are in general taking 10 in SI. Okay, we will substitute the values. S is the height, U is 0 into T plus half G T square equal to half GT square. Equation is reduced. Say, in between the two droplet, capital T second is the time interval, because it is mentioned the drops are falling at the regular interval. Means the total height traveled by the first drop is in the time t plus t plus t 3t. That's why h equal to half g. At the place of the t, we are going to substitute how much? 3t, capital T, 3t whole of square. Value of h is given to us the 9. We can solve it out for the t square, or we can find the time interval between two consecutive droplets. Half g is 10, 3t whole of square equal to 9. 3 square is 9, that is cancel out. Therefore, t square we can find 2 divided by 10 means 1 by 5. Since second drop traveled the twice of t second only, second drop t plus t. Similarly, we can sort it out. Half multiplied by g multiplied by 2t whole of square equal to half g, that is 10, multiplied by 2 square is 4, multiplied by t square, value of the t square already we find the 1 by 5. 5 to the 10, 10, 10 cancel out, what we are getting the 4 meter. Means in 2t second, the second drop traveled the 4 meter from the tap. Total is how much? 9. 9 minus 4 is 5. Then the separation or the height of the second droplet from the ground is the 5 meter. This is the conventional way. Now we are going to solve the problem with help of technique. Let's check. Ratio of distance traveled in free fall in gravitational field. We know in first 5, 15 and 25. Means always 1 is to 3 is to 5. Isn't it? Look, 5, 15 and 25 meter only traveled when there is a interval of the time is the 1 second. It may happen the interval of the time between the two droplet is lesser than 1, then the distance is lesser, but ratio is always 1, 3 and 5. Just check it out in our problem. Look, the total height is given to you the 9. If this is 1, 3, 5, 1 plus 3, 4 plus 5, this is 9 meter. It is telling 1 plus 3 plus 5 is the 9 meter. For the second drop, it is very much clear from the diagram. D is nothing but 5 meter. How easy to deal a complicated problem. So cheer up, you're getting some new tools. You are learning something new in each consecutive video, isn't it? How to solve physics problem in a smarter way. You are on the path to growth. Thanks for watching. Stay tuned with me. See you in next video. How to solve problems on vector. Thank you.